hit record, and we're good to go. So today's topic, Pospi, do you want to summarize what we'd like to cover today?
Sure. So we've talked a lot really lately in the context of Chimera about compile time frameworks. And there's a whole component or avenue, I'm not sure which, I think it's a component. Like these things are all modularity, and I've kind of been thinking about, how would you depict this, starting at like the smallest pieces of entries and links, and then, zooming out and zooming out. It's all modularity. But we've been talking about it from terms of zomes and how to stitch things together in zomes more easily with some of the tooling that Philip's built. And today, last week I tried to talk a little bit about what more dynamic composition of modules looks like from a runtime rather than compile time point of view. So being able to take things and assemble them without any programmatic knowledge into complex networks, basically. And I've made a little bit of progress on that. So I think I'm hoping that after today I can have conveyed what I was trying to convey last week, basically. And there's a few things we might want to dive into as rabbit holes that come from there, or we might just stay on that topic, I'm not sure. Yeah, does that sound like an interesting avenue of exploration for all involved?
Yeah, I think that is interesting. And I would also suggest, like, if people can jump in with their questions, don't wait for an opportune moment. Like if you have something, just drop in the chat or just unmute yourself and ask the questions. If you'd also like the speaker possibly to break it down into more tangible examples, don't hesitate. Don't assume that others don't have the same question. They probably do.
Yeah.
Yeah. So
we can do even this symbol for the clarification too. If I start using jargon you don't understand, we can do that. That's a good one. Although you'll have to shout, Sid, because I'll probably not be looking at the Zoom window when that happens.
Yeah. Yeah, other stuff we could also, if we've got time, we could get into GraphQL and how UI fits into all of this. We could also cover, no?
Yeah, well, no, that's actually probably mostly what I'll be talking about.
Oh, okay.
The kind of modularity I'm talking about today is actually less about holochain and more about UI code, I think.
Oh, okay, cool. That
it
that
plays
simplifies things. Cool. And if we want to get into it, we'll also get into the specifics of some of the Lego blocks that I mentioned. So not just REA, TM also asked me to mention the mutual credit package that is ready to go. I could also touch upon some of the reputation libraries that we've been building. Yeah, so let's see how we go with time. Before we go though, Greg and on Arya, do you want to share a quick line on just summarizing yesterday's hackalong? Just real quick, or if you want to.
I'm prepared, Ari, but I'll let you go because I briefed on you guys to them.
Okay.
Yeah, I tried to summarize yesterday, and then our last week's meeting. So, Ari, you want to do it or shall I?
I can give it a shot and then you can add to that. So basically in today's hackalong, we had a conversation around conductors and just understanding how conductors work. That's what we did.
Okay. Cool. Awesome. Look forward to the recording. Okay, take it away, Pospi.
Yeah, and I should apologize too. I have a bit of a flu or a cold or something, so I'll be pausing to cough frequently. Sorry. Yeah, this is a bit of a list I have of things that we need to talk about still, and probably this highlighted section is what I'd get through today. But we can, if people decide to jump into group agents and things later, we can do that. And probably this one might be one for next week, Sid, but you talking about some of the modules that you're developing is a good lead into that, because we can start plugging them together next week, maybe. Yeah, so I think the easiest way to convey this is to kind of walk it through in terms of how it's been developed. So I'm just going to go back a bit to my master branch. What I want to get to is some of the work I've been doing with the client-side framework with HoloREA, and what that makes possible that we haven't really talked about yet. So I'm just going to pull open this init file in my test harness. And this is a Node.js test that uses Triorama, but it's going to be similar code to integrate this into a UI when you get to doing that in a front-end app, which might be the week after next when we talk about those kinds of things. But the thing I want to show here is I've got something down here that builds players. And you've all seen the Triorama players where you do this scenario.players and give it a bunch of player names and configurations, and it generates you different people talking to different DNAs. So that is actually just standard. And then I've got this other method, build GraphQL, that adds a GraphQL API that wraps around all of the DNAs that have been made. And there's a few things about that you'll notice in this implementation. So one is I've got this neat framework here called Easy GraphQL Tester that literally just lets you run GraphQL in a test synchronously. So that was a nice module to pull in. But you can see there's also so this build GraphQL method, after you've built the thing and created it with the player, it gives you back an async function that you can run with the GraphQL query and the parameters that'll actually execute the query. And if you look in some of the tests, it ends up looking like this. So you can see here I actually inject it as a property of the player. So then here I've got one of these players and I can run a GraphQL query and just here's the query and here's the data for it. It's actually a mutation in this case, but it would be the same without parameters if it was a query. So that's how the existing stuff with HoloREA has been working in terms of how GraphQL talks to DNAs. And then actually if you go and pull open the module itself that does the work, and let's look at the one that we're looking at to make it a bit more useful. So create intent. So if I look at the create intent mutation, here it is here. So you can see there's these bindings up here where I'm pulling in the zone function from the holochain connection. And this one has had some edits to it, but it's more or less idiomatic in terms of what most people use. And these zone functions where you tell it the instance, the zone, and the function name, and it runs things for you after that. So this is where I'm actually doing the binding to holochain within the UI or within the tests, either or. And as you can see, there's been this to-do sitting there since the beginning of how do I make this DNA identifier dynamic, because if I want to connect to multiple planning networks, then I can't just go and connect to planning anymore. It doesn't, there needs to be more ways to configure this. Does that all make sense to everybody so far?
I feel like there might be a step here. Could you, just for everyone on the call, articulate why GraphQL and how it's playing in the role it's playing in the larger picture here?
Yeah, the answer to that is kind of like I mean, it's been covered a million times. I wonder if there can be some generic article that finds this, but you'll find heaps of them. Why it's the future, why it's important, why and why. Most of them are focused on why you would use it over a REST API, because that was always the way of doing things prior. What it gives you that you don't get with other things is this very, very neat separation of concerns. So in here, this VF GraphQL holochain module has all of the logic that makes my UI talk to holochain, and it's entirely contained within this module. It doesn't have to be anywhere else in my app. If we look at, say, this, I think there's a newer version of this module, but I'm not sure it's filed. This one is a little out of date. But this one is a similar implementation of value flows, actually. So it's REA as well. But this one here, you can see it's doing it over Scuttlebutt. So it pulls in some code from this SSB helpers package, but then it's just got much the same resolver callbacks here. So you just have these functions that get called by the framework. You know, so this is how you query an agent's details, how you query the types of resources, how you query the resources themselves. And all these functions are the same, it's just the logic inside it is different. So with Scuttlebutt, there's all this logic to pull stuff out of the Scuttlebutt data store. And with REA, let's look at one of the queries so that you get a sense. With REA, it's the same thing, except you're pulling it out of Holochain because you're binding to these zone functions, and that's what gets actually called inside of each of the resolver callbacks. So that's one big benefit. And then the other big benefit is that when you get to actually authoring your, I have to open a project for that. When you get to actually authoring your UI components, say here, this might have one. Get resources. So these, you can see when you author queries in a GraphQL app, every component that you bind data to, you include the full query that binds to every field that you're requiring from the API. And what that means is you get these extremely tight bindings between the back end and front end. And now if I tried to run this, it's an older app and some of these parameters are non-standard. So it'll throw me a bunch of errors and tell me that the query is wrong and doesn't match the back end. And it gives me the same in reverse. So if I upgrade the Holo REA schema and resource specs, then the queries will all be invalid. And that kind of tight binding and hard breakage is what gives you all the reliability that GraphQL provides, because when you're dealing with REST APIs and things, you don't have all that stuff. So often someone changes your server and you have different data and your front end breaks and you don't know until it hits, well, UAT, hopefully not production. But yeah, these are kind of well-known problems that GraphQL solves because it has that tight schema binding. Does that answer your question?
Yep, thanks.
The other nice thing about this is that at some point, because this runs and talks to the value flows spec, so there's I've talked about it on a few different occasions, but there's this GraphQL schema that actually specifies all of the value flows protocol and thus REA. And so it means that services like Holo REA can implement to this spec. And if you implement to that spec, you're completely pluggable with another backend. So this Commons Pub project is probably the most mature thing. Might even be getting more mature than Holo REA at this point. But yeah, that'll just, you know, plug in separately as a different backend without needing to change any UI code, which is pretty cool. Anyway, so this is how it used to work. And just looking at the way this GraphQL query here is run, I wonder if anyone would like to have a go at explaining some of the problems they can see with this. Just shout out. That's cool. Well, it's my code, so I'll tell you about it. So there's a few things here. One is when you look in this connection file here, I've exported a function here to set the connection URI to specify basically which conductor you want to connect to. The thing about Triorama and tests is that when you go and you build all these separate players like this, they're all actually running on a different conductor on a different port, I think, different URI. So you actually need to be able to, depending on whether I'm calling the customer query or an exporter query, it's a different, excuse me. It's, where was I going with that? It's a different API to hit anyway. So what I'm actually doing here is every time I run the query, I call this global method that overrides the connection URI that's kind of like global state within this connection file that talks to Holochain. And basically I just do it every time to make sure that it's in sync. So it's not great because you have this global state here that you have to kind of come in behind and poke at every time you want a query to run in the right place. So that's kind of the way that the issue presents there currently. Now, let me just close that and take you back to the stuff I'm working on, which I'll probably merge after this call, I think. So this is what the tests look like now after some of the changes I made in the last week. And now when you come down and look at this build player method and build GraphQL method, you can see that actually the tester is being created inside of the GraphQL method now. And there's no longer any kind of global state, and I don't have to jump in and run this set connection URI method anymore on every request, because when I create the tester, I'm actually now passing a conductor URI, and I'll get to the DNA config later. But I'm passing that into the tester as something that's going to be kept inside its own state internally, is inside the closure. So what this now means is that there's no more global state in the connection that I really need to care about. I can create separate people, and their GraphQL APIs are all actually entirely separate, rather than all kind of interfering through this global holochain conductor thing. So that's kind of a nice side effect of what I've done, but it's not actually the reason I did it. So looking at the resolvers now is probably the next best thing to do. So, or maybe even the top level API actually. Hang on, I'll go back to master. So just looking at the top level API for the holochain GraphQL connector module here that connects HoloREA. So there's some stuff in here with VF GraphQL that sort of dynamically generates the part of value flows that HoloREA is currently implementing. But you can see the old method, if you've used GraphQL before, you'll find all this very standard. Like there's resolvers, and if you go and look at what the resolvers actually are, you can see they're all just actually all these exports that are the resolver functions. So you end up with that totally standard GraphQL thing where you just have like a whole bunch of different resolver callbacks in an object, and it knows how to apply them to the schema. But then you still got this problem of you have to inject the DNA identifier and override connection URIs and things every time there's a different user running on the same instance. So this is what it looks like now. So basically, all of these places where it was previously just giving you an object, I'm now giving you a function where you have to specify some optional conductor, some optional DNA mappings, and an optional conductor URI. And that all gets all pumped through everything. And it again means that now these bindings are internal to these resolvers. And back to the root file here, you can see I actually gave it a bunch of options. And so there's things like which value flows modules are enabled, the conductor URI, so you can connect to multiple holochain conductors with different GraphQL APIs and run them all in the same script. But the DNA config is actually the really important bit. And all it is it's just a mapping of the DNA identifier to some runtime instance name. And the DNA identifiers are just the folder names under HAPS here. So there's agent, observation, planning, proposal, and specification at the moment, and there'll be many more. And as it says here, if it's not specified, they're bound to the default instance names, which are the same as DNA IDs. So basically now, when I import VF GraphQL holochain, you'll see here, I'm calling this generate resolvers rather than just bringing the resolvers in together. And that's where I give it this object with all these options where I can specify DNA configurations and conductor URIs. And what that finally means when I get into the actual tests or the UI, whichever you end up binding to, is that down here where in the previous one I didn't have any of this code, I just was generating the standard API. But now I'm adding some additional GraphQL endpoints that are wrapping over some of these DNAs. And so I've made the customer now has a GraphQL API that lets it talk to the couriers network. But instead of using the observation DNA, which it doesn't actually have, the customer has no observation DNA here because they're just talking to a marketplace. I'm actually going to bind it to the courier observation DNA. And that's all you need to do. Now I have two separate GraphQL APIs that are separate collaboration spaces that are entirely independent still, but they're things that that agent has access to all at the same time. I might just pause there for questions.
That's interesting because I think for the first time, I'm starting to get a glimpse of what you've been talking about in terms of collaboration spaces and why it's so important.
It's working, yes.
Anyone has questions? I have some thoughts on where we could go from here.
I've just got maybe an
Yeah.
observation,
Hmm.
maybe to
Yeah, go
ask
ahead.
as a question, so I've confirmed it. Thanks. So now you're doing everything in JavaScript, which is cool because I can like understand that 10 times better than Rust. And is the reason for that so that you can use GraphQL, because GraphQL doesn't exist in Rust? Is that right?
There is actually a GraphQL implementation in Rust. It's called Juniper. Yeah, this one. It's just, you know, Apollo tends to lead the way with its feature set, and there's some things here that are lacking that you get in JavaScript land. People have done experiments of bundling the whole Juniper runtime into the Holochain conductor and then just querying it like, I think, a REST server, or no, it'd have to be WebSockets, I think. So yeah, you can do it. But the reason I'm doing it all in JavaScript is that, well, with Holochain, really, there's not much difference in the security environment between the browser and Holochain. Like Holochain, you have signed code and it's all ensured to run the same way on every node, I suppose. But you know, in terms of what that machine is, it's still just your local machine. So you have as much room to mess with it and change the clock and all kinds of stuff on the node as you do in the browser. So there's not a lot of difference to the security model where you do your logic. And I really am very against putting little bits of centralized infrastructure in places to deal with bindings. Like I see some people putting Node.js servers in between Holochain and the browser so they can run GraphQL queries. The push here has been, I want an entirely client-side GraphQL binding where everything happens through the browser, there's no intermediaries, and it'll just talk to the Holochain WebSocket. And so that's why I've taken this route of binding things directly into Holochain and calling them out. I'm sure a lot of this could be done automatically and generated in future, but at the moment it's all by hand. So it's not there yet, and it's something I want to get done for next week, hopefully. But there's kind of a next step with this stuff. Now that I've got an ability to create multiple GraphQL APIs for people that they can kind of look at different sets of collaboration spaces with them. The next thing, well, let's talk about a few things with this actually. Well, yeah, the next thing is being able to compose the value flows GraphQL APIs. So when we were looking at what Philip was showing in Chimera last week, he had kind of like a network context switch. And depending on the network context he was in, he would see a different set of agents in the chat list of who was in that network. I don't want things to work that way. So what I want to be able to do is basically take, like say here.
Sorry, one sec. Is that Sam? Is that you? Can I mute you?
Yeah.
Oh, sorry.
Yeah. Oh, there you
go. So where the exporter here, they have access to their own planning space as well as a subcontractor's planning space. The way I want that to work in value flows, as you know, your perspective as an agent who's kind of part of two collaboration spaces. So you've got this broader collaboration space where you're involved with your own company as well as a subcontractor. Oh man, where was I going with that? Yeah, so what I need to be able to do is basically take these two separate GraphQL APIs that I've currently got for the exporter's agent and planning and the contractor's agent observation and planning. And I want to be able to basically glue those together into a higher order GraphQL API that knows that, you know, if I want to pull a bunch of commitments, it'll go to both networks and pull the commitments and order them properly for you and then spit out the first 10. And then, you know, when it can't find more, it'll request more behind the scenes and that kind of stuff. So that I've got not just the people in my network at one time, but I can actually communicate with everybody across all the networks all at once. And I've realized that that's a really good idea for reads, but it's not a very good idea for writes. So when you're putting data back into the network, you're always going to tend to want to have deliberate control over where you're publishing the data. So in this space, it's like, if the subcontractor does, excuse me, if the subcontractor does some work, you know, do they want to publish to say that they've done it just to their own internal team, or do they want to publish to say they've done it to their team and the contractor who's asked them to do the work, or do they just want to send it to the contractor? And I don't think there's any one size fits all answers to that. You kind of need, like, on every publication to have options to say which networks you want to broadcast this information to. So yeah, I think that's the next step for this. And the other nice thing about doing it this way is that because I'm building the same GraphQL API for every service, so like this exporter here, the GraphQL queries that talk to agent and planning are the exact same as the GraphQL queries that talk to agent and planning here in the contractor GraphQL binding. So what it means is that the UI doesn't have to think about which network it's posting stuff to at all. In terms of the actual components that do the data entry and saving and stuff, you just need to have something kind of parent to that lets you toggle out which GraphQL API you're talking to when you submit the data. And you know, you could easily do different compositions of that dynamically, I think, as well. So it's a bit of a headful, but that's where I'm heading with GraphQL. And I guess I should also point out that there are aspirations to this beyond HoloChain. Like, I want to be able to create a GraphQL API that talks to Scuttlebutt and compose that in here so that I can then have an economic system that has data that moves between HoloChain and Scuttlebutt seamlessly. And I want to be able to plug in CommonsPub as well and have, you know, federated offers and needs being run from HoloChain that are being matched in CommonsPub and vice versa. So those are all very interesting possibilities that can come out of this, that are mostly made possible, I think, in any sane and reasoned way by the GraphQL tooling. Like, without that, you're going to be passing around a lot of random data and state, and I don't think it's going to scale well. I'm open to be proving wrong, though.
I have a couple questions that are coming up. First one is, could you articulate a little more, like, how you see Philip's approach and where that actually differs from here? Like, I feel like I get it, but it'd be nice to hear your perspective as well.
Yeah, we talked on Tuesday, and I can see this vision where both approaches work together quite well, because I can almost see it that, you know, Chimera and CRISPR give you this thing that you can bring in a bunch of stuff that other people have created as these pre-built building blocks, whether it's REA or reputation stuff or whatever. But you can also fairly easily author your own things and customize the ones that you bring in potentially. So I'd almost see it as like a Chimera install ends up looking like your whole organization's digital toolkit, and you can, your technical people can go in there and create these very low level artifacts that are perhaps custom to your specific collective that you might need that no one else in the world needs. And all those back end and front end components can be stored in there, kept in Chimera, synced on HoloChain. And then it's not until you actually get to the runtime deployment of those as active DNAs that you're actually assembling the Lego blocks into something that is the specific culture, as you're calling it, that your organization needs to have. So yeah, the very short version is Philip's thinking about it in compile time terms and mostly about what goes on inside a DNA. And I'm thinking about it in runtime terms and, you know, what is dynamic and shifting and changing and what goes on between DNAs. It's kind of the best articulation I have for it at the moment.
And if we were to dive more specifically into the UI end of things, like the fact that he's not using GraphQL, the fact that he's using, like, from my perspective, it seems that the kind of modularity that you're getting in at the front end is just not possible with Vue, right? Like,
I mean, you can use GraphQL with Vue as well. He's just chosen not to at the moment. Yeah, I mean, how many years has it been? It's like, it's more than 5 years of work's been put into GraphQL at this point. So, and I think mostly Philip's UI code is kind of just calling HoloChain functions directly. You know, there might be a certain amount of code organization and modularizing that he can do that makes that sane to reason about and deal with as the application scales. But from my books, you're really just kind of reinventing a lot of the wheel that GraphQL gives for you, and GraphQL's always going to give you more because it has this rich schema language and type specific bindings and really good error messages and all that stuff. Yeah.
Cool. That is helpful.
Yeah.
Any
Tell us about
questions?
some of your components. Well, yeah, let's do questions first.
Yeah. So I would like to ask something. This is because now I've been following the CRISPR and what you've been doing. So I just want to understand from a user perspective, your end user perspective. These are going to be developers who would be using your tool to develop some, say, some Hedge apps very quickly. So can you speak to that a little bit and compare both applications?
Sure. Yeah, Philip's approach, it may be possible to get it to a point where a certain level of non-technical expertise is all that's required, but at the end of the day, it's still a technical framework meant for developers, I think, at least at this stage, and requires some technical know-how to tinker with and change things. Whereas the eventual goal with the runtime modularity stuff, which is just being able to plug DNAs together differently, there'll be some stuff for developers in there too, but it should be at the point where a non-technical person can just join DNAs together and do different arrangements of things and do it all without needing any crazy knowledge or anything. It'll probably start to look more like that once the what are they called, zone traits start to get hooked up between it. So there's sort of like deliberate stuff that says you have to bind a resource type module here and that kind of thing. But that's all stuff I'm just waiting on the new HDK before I go too deep into. So yeah, I think that's the primary difference. But the side effect is that the way that Philip's thinking about modularity, you can tinker with stuff and generate a DNA, but once you've generated the DNA, it's kind of fixed. And there might be some promising avenues in terms of migration frameworks to upgrade from one DNA to another and to move configuration from one DNA to another that allow that to be an easy path forward. But with what I'm doing, it's assemble things together, and as you're running, if you want to pull something out and swap it into something else, you can do that, and it can all change dynamically without it needing to be recoded and redeployed.
As a tangible example, do you want to get into, like, let's say I wanted to create a mutual credit system. What would it look like if I were to use GM's DNA right now versus doing it in the REA approach?
Can someone tell me what it would look like with GM's DNA? Because I don't know much about it.
I mean, it's just a really simple, you've got a basic, like a little lobby where, once you download the program, once you download the DNA, you wait in the lobby, and once you get 2 vouchers, you're included into the club. And once you're in, you can transact with any other person. It's just, you just pass private entries for every transaction. But every time you want to get into a transaction with someone, you check the header of the person to ensure like everything adds up. So I would say it's a very specific app designed for mutual credit, obviously, because it's a DNA designed to do that. But if I were to do it in the REA approach, how would my thinking have to shift? Is more my question.
Yeah, I don't think it has to shift much at an outset. In a simple case, you could just kind of make those same choices. But I guess the difference would be that you would be making choices then, and it's sort of up to us as to these preset configurations we deploy and how prescriptive we want to be versus how much we want to let people find their own way. But it would be like, okay, I mean, for a mutual credit system with REA, I need to deploy an observation network to observe the flow of resources in currency that goes between people. I might build a separate module that plugs into that does spending limits and things.
Yeah.
I've actually hang on, I might find the GitHub issue. Because I actually put this idea together just as a thought the other week, but I think it kind of is a good idea, because at the moment the observation DNA in Hollow REA, it's got events and resources and processes all in there. But when I think about GM's mutual credit and the version of it that doesn't have spending limits, there's a way that Hollow REA, if you don't have the resource inventorying component, then you can use it as a dynamic event store that works like mutual credit, where you never actually store the resource, so you don't have any conflict. So potentially, if I go and modularize this a bit more, there might be more choices that you could make around there as to whether you want to have people conflict if they try and make two spends simultaneously, or but prior to that, it's a lot of choices around it sounds like with what GM has at the moment, it's all fairly prescriptive of the agents have this vouching mechanism to get in, and this is how it works. Whereas with Hollow REA, it's like, okay, which agent module do you want to use? Here's one that's totally public and unrestricted. Here's one that has vouchers. Here's one that has an administrator role who administers who can be allowed into the network. There's a whole bunch of different ways you might choose to manage user access that I don't necessarily want to enforce on on the whole of Hollow REA. I want to give people a choice by just being able to plug in something that does REA agents in a way that Hollow REA understands, and then they can use it whatever logic they like. Does that answer the question?
It does, and maybe I can add my perspective just to see if I've got it right, and might help others as well. It feels like if I'm thinking about a system or a mutual credit system as part of a much larger system, which is where a community or a business or an organization or an institution that's decided to use mutual credit, but we want to have very specific control over who gets to access what transactions, and what are the conditions that might even open up access. Let's say I'm the government and I want to establish mutual credit currencies for people within my sphere of governance. I actually can design a system where if a warrant is issued, I have tokens which gives me access to observe transactions. So those kinds of very specific designs can become actually really easy. You don't have to actually hard code them. You could actually just use REA's levers and then design them. And if I want to do other funky things like modulate the supply of mutual credit on the basis of something like reputation, like the number of likes or claps you have defines the mutual credit limit that you have, then I think that becomes easier with REA, and then I don't have to go in and hard code some of that. So yeah, that's the way I'm looking at it, why I would choose to go down an REA path. But yeah, if I'm just, a bunch of friends want a mutual credit app, then I just, with the specific design that GM's created and it's fine with me, then I would, just roll out with the mutual credit app. Cool. Yeah, I guess.
Yeah, we haven't, that's a good analysis. We haven't really talked a lot about how to do that kind of selective disclosure of data. And it maybe plays into,
I feel like I shouldn't have used the word government. But
I've been playing with the way that I try and describe this, because I think when I see things like roles being implemented or user profiles being implemented as a zone within DNA, REA is going to have roles too. It's not that they're bad, but there's definitely a difference of direction between, I feel like a lot of people are building in the direction of creating auth structures inside networks. And I'm more building in the direction of using the networks as the auth structures themselves, because I think holochains DNAs and the way that they bridge and connect kind of gives you maybe all the primitives that you need to do that kind of access control. So that's why, you know, I'm running with this pattern of I want to have like an agent controller DNA that everyone registers with, and then have this delegated authority zone that lives in all the other DNAs that just asks this zone, is someone a member, and lets them in if they are. Because to me, that is much more of the like, this network then is everything that's shared between these people, and if it's a different set of people, you use a different network, and it might overlap with that one somewhat, but they're separate spaces really.
Yeah, that makes sense, and I think that articulates the difference in approach as well. Just off the bat, like one thing that comes to mind is I'd love to, like, I feel like what's very possible is just creating a simple mutual credit system on REA, but with a couple of levers. Like we could have one of our reputation libraries plug into it, and so as the level of reputation fluctuates, the limit fluctuates. You could have like the observer module decide who gets access to transactions and who doesn't. Like it'll just be I think a simple example of what is possible with REA. Yeah, that would be a fun thing to do.
Yeah. On the selective disclosure stuff and that concept of the networks as the auth structures, like I've been wondering whether it might work well. You said something just before about it sounded like it was like a selective disclosure thing in mutual credit, but
like
maybe
who can observe transactions.
Yeah, there you go. So so the way that is maybe the way of doing that is that you have like a core network with all the trusted people where, you know, everything is public in that network, but then you might bridge it to another network that has the selective disclosure and only pulls in some of the records, and that's the one you share publicly externally. For me, that's very much in the networks as the auth structures pattern. But yeah, I think that could work. And I've also been wondering whether that might even work dynamically, like this DNA that does the filtered sending doesn't actually store anything. It just bridges to this one and reads the data, changes it, and sends it out. But I don't know if that is how bridging works when it's sort of bridging to a remote person, or if they would have to have access to the internal data to do that. I'm not sure. I think with a capability token, you could do it.
Yeah, that's what I was thinking too. And that's where it intersects with some of my thoughts on that reputation vault, because like the reputation vault would decide who gets access. Like I've been thinking about that, but on the reputation perspective, but I feel like it's the same, almost the same to also do it for REA transactions. So maybe there's like a common design that we could explore there. Yeah, cool. Keep questions. Keep coming in with your questions.
I'm just gonna drop Guillaume's remote bridge into the chat because I mean I know you and I tried to understand it and it was a little bit weird, but I think that probably does most of what we need for that kind of bridging we're talking about.
Yeah, so the way I've understood it is you basically identify who, like the assumption is you know which agent on your network has both DNAs installed, and you send a message to that agent, and that agent opens up the bridge for you. So it's the assumption there is you know who the trusted agent is. Or there's this very simple process to discover who is a trusted agent, who does have both DNAs installed. That's what he's implemented for mutual credit, which is a pretty interesting design pattern, I thought. Cool. Should we keep going? Got about 10 to 15 minutes more.
don't know if there's anything here short enough that I'd want to get into as another topic, but
maybe
you
if
want
I'll
to talk about
change
something?
the subject.
Go for it.
I've got so I've signed up to the Commons Engine Udemy, however you pronounce that course, which is about
currency design,
creating currencies. Yeah, so I was wondering if there's. It seems to me there's a relationship between what Positive is doing and how that might pull together. Is that right, or they're completely separate?
Don't know. I think they're probably related casually, but not in any deep sense. I know I've seen it. I wonder if anyone here knows where. I've seen at least a screenshot of a tool that Art's been toying with of like this thing that can generate random, currencies. And it's this maze of options of all the ways you want your currency to behave. Click a button and away it goes.
it's a little Prezi.
So I don't think that's. Yeah, no. This was an actual app, I think. I might try and find it while the people talk. But I think that's something that Holochain finding it.
But Sam, to your question, I think there is a lot of common ground, and there's definitely an understanding within Commons Engine that if you are looking at currency design, especially for the monetary bit, REA is probably the easiest way to implement some of it. But I think Commons Engine, like most projects associated with metacurrency, are constantly talking about currency design across the spectrum, so not just monetary but reputational, and then also thinking about the governance, etc. Yeah. How far have you gotten through the course entirely?
No, I just signed up to it last night because it was 20% off. I saw on the Twitter feed. So
but yeah, there's a bunch of interesting things in there that Art talks about. And you'll see some stuff about reputation currencies as well. So it's a cool package. Yeah. What do you think we should do, possibly? If there's any questions, roll in, or we could maybe pick up a small topic for about 10 minutes, 15 minutes.
I have no big suggestions. Couldn't find the project, but I did find Art's giant currency decision in space map. It's in the chat if people are interested.
Maybe we could get into one of the reputation libraries and just run through it in 10 minutes. I'll just share the resource for it and share my screen. Cool. So as most of you might know, this is part of a larger thought process called neighborhoods. And I feel like that's probably worth its own hackalong session at some point as that develops. But the thinking there is within agent centricity, it's getting really simple for people to pick and choose and stitch together like very generic tools. So if I want to, pull together a simple economic network using REA, which is, we need a mutual credit currency for a community, and we need to figure out who can observe and what's the governance behind it. Well, we'll use some of the REA tools. If you want some basic UI tools, for communicating between each other, we can use some of the modules again that Bossfee's created. And so what's critical in agent-centric worlds is for you to be able to articulate your culture very clearly, which is, what is your reputation systems, and what are the modules that you want to be using for it. And which is why it's intersected really well with the modularity conversation again, because I see great value in reputation libraries being implemented as separate DNAs in themselves. So let's say Sam or Kamal, like you guys are implementing your own communities, you might have a specific view on, I want to reward behavior with a like, or I don't like likes, they're too, they're not appropriate. I want to use the upvote, downvote mechanism. or you might choose any other system that you might want to validate actions. So you don't actually have to design that yourself. You just pick and choose your DNAs based on what's appropriate to you. So you actually just swap it in, swap it out. You can also choose if you want likes that are private, likes that are public. Um, and so do you want everyone in the ecosystem to see who's liked, activities or items that people are posting, or would you want to be more private? So you also have those kinds of options. And sort of like the first library in this whole series is a simple likes DNA with public entries. And the way that works is you've got something known as a base entry, and this was a pattern created by POSPI last year called threaded comments, which is basically a base entry can be defined as anything. It could be a post, a blog, a video, an activity, an economic transaction, anything you choose, you can attribute it to anything. And this DNA attaches likes to that base entry. And so what's interesting is all likes or claps or whatever the reputational activity is get stored on a DHT of its own. And that has interesting implications, because that then leads us to a situation where if we want to issue certifications, badges, any kind of scores or labels of any sorts, you just bridge into this DHT to figure out how many likes Posby has, how many likes Sam has. And what's more interesting is I think this structure works really well if you want to query across DHTs. So let's say Sam has an interesting community of his own, but he also likes Sid's community. And he wants to issue badges based on activity across both communities so that he can actually aggregate likes received both and actually do a mathematical operation and issue a badge or a label from another specific DHT. And so what this means is bridging of reputation across communities becomes a lot easier. So when an agent is going from one community to another, they're not going with the reward, like they're not going with the certification or the badge or the label, but they're going with their underlying data, which is, here's the number of likes that I've received, here's the number of claps, or here are my timestamps. And I think that really helps in the long run, like deconstructing reputation into a far more objective layer. But yeah, the intention is to use this likes DNA. We've been chatting with Hidayat and Guillaume to use this in Leap. So those who've been following, Leap is part of the other hackalong. It's one of the main projects, which is a simple e-learning platform. And so as part of that e-learning platform, there's courses and teachers that need to be rated. So we'll try and use this DNA to rate the courses or the teachers. So that might be one of the first implementations. But yeah, after this
Right,
conversation,
can I just ask a question?
yeah, go ahead, jump in.
So that sounds like if I've got my community and someone's done a course on whatever in Leap, they can then use that accreditation of that course in my community as a different
absolutely.
representation.
Absolutely. And what I'm really stressing here is, like, you don't show up with the certification, like because I don't think that's can be of as much value. Like, you don't want to see, oh, you're a 5-star, you're a gold level teacher from Leap. But what might be useful for you is, oh, here's the number of courses you've done, and here's the ratings that you've received, like the underlying data, because maybe that's more important to you, and maybe you want to issue your own psychologically relevant label to it, right? And that's what will be more useful.
Or vice versa, if someone's done, say, when you do a university course and you get credit just for having been working in that field for 20 years or whatever, You don't have to start off at the base
Absolutely.
level. You
Yeah.
can jump up to the master's level.
Yeah, that's the objective, and I think that's what modularity really gives us in the long run, right? That portability across communities and tribes. Yeah, I think.
Sid, can I just ask you
Yeah,
something
go
about
ahead.
that?
Yep.
You said before the base entry could be anything,
Mm.
so any transaction, but then you said it's linked to an agent. So what if the action is linked not just to one agent, but to multiple agents?
The agent that I'm referring to here is the agent issuing the rating.
But the one receiving the rating, so
Yeah,
the one that the base entry is connected to,
correct.
what if that is not just one agent? What if it's multiple agents?
So it's, let's say there's 5 people who've created a documentary or film or a course or something of that sort.
Yeah. So how would you then link
Mm-hmm.
that base entry to those 5 agents?
So the likes DNA doesn't really do that. There is a conversation currently underway with the Leap team on whether we want to bridge in that information. But for example, if there are multiple teachers who teach a course, then that's the reality of the system. The base entry has 5 agents associated with it, and those 5 agents have received this rating, or that course has received this rating. Does that make sense?
So basically, every base entry is
Hmm.
connected to one or more agents to
Correct.
link where the likes or claps or whatever end up.
Yes. Yeah. But the rating is specifically towards the base entry.
Yeah.
And so at a later point, that agent could claim, oh, I'm part of this base entry that has received these ratings. It's like a director can say, I created this film that received these positive reviews.
Yeah.
But that's how we're designing it.
Great. Thank you.
So if there's like, this is a really tangible use case. If you want, like, we're open, like honestly open to anyone who wants to use a simple ratings DNA for their project. I'm kind of excited about doing it for the mutual credit one as well, possibly. So maybe if you've got bandwidth, might be fun. And another thing that I just thought of was, currently we're hard coding the public and private stuff for each like. Maybe we don't. Maybe we use the observer module for something like this. I don't know if it'll be overcomplicating things.
That may be overcomplicating things. I find likes to be a very different type of thing to an economic observation.
Yeah, because the thing what I'm thinking about here is, like, if the likes then anyway, I'll message you. It might be an overcomplication right now, but there's definitely uses for it, because technically then the user doesn't have to worry about the whole community knowing about their likes. Like, maybe just a few people in the community need to see it, and so it gives you control over how it spreads within the community.
I reckon it'd be fun to live code it next week. I think that's pretty achievable. It wasn't really my intention for it to be used as like an app bootstrapping tool, but the GraphQL stuff I've got with whole REA, I think it'd be kind of fun to just plug likes in and have it work through the graph and see how it all binds together to add something custom into an REA network.
Yeah, it could be cool. That'll be fun to do. Yeah. Awesome. Any questions coming up, guys? Or we can start winding down. Okay.
Thank you so much.
Thanks.
See you next week.
Yeah. Thanks, Baspi. Thanks for showcasing this. And what do you think? Where do you think we go next week?
Well, depends which thing I find time to do. I mean, we can do the injection of custom functionality with likes. I think the only thing stopping us with that at the moment is we're targeting 2 different versions of the HDK, aren't we? Otherwise,
yeah.
Otherwise, group agents maybe, if I get time to put some sort of a test spec for that together.
Yeah, group agents might be interesting. Even to have an academic discussion around it.
I've seen how those academic discussions go.
Awesome.
Hey guys, sorry, I have a quick question.
Yeah.
I'd just like to check with you all because you all have been quite hands-on with the coding. Where do you have a sense of how far away are we from Holochain being ready to actually design apps that can be used in production? How far do you see we are to actually beta launch of the Holo network? Do you have any sense for this
I have
area?
a slight sense after talking to Philip earlier in the week. I'm just going to pick a number out of the hat and say 2 months. I think the progress that he gave was that like the core rewrite, you can now interact with it. It's all working and the WASM runtime's there, but there's no HDK yet to do it easily. And I suspect that's a bit of work, but that's the only thing I think that's the big missing piece to have that big upgrade land.
So that's for the Holochain part. How about, am I understanding that correctly?
For the Holochain what, sorry?
You mentioned that you have a sense that within 2 months it might be ready for that. That's for the Holochain part. How about for Holo?
Yeah, I think they're kind of the same thing actually at this stage, because my understanding is the big need to refactor some of the core stuff was because they were having trouble with the current networking implementation. And the networking implementation, I think, is the only thing that's really left to finish off before Holo is kind of a production thing. So I think it's kind of the same job now, I think.
I see. Cool. Thank you so much.
Yeah, and I can also add, like, the feedback we've been getting about the refactor is pretty positive. So honestly, I can't wait. Like, would you say orders of magnitude faster than what we currently have is what I've heard. So let's see.
I mean, I would say that, but I'm kind of butthurt about what we currently have, because it feels like the last few versions have, like, performance has gone bleh kind of thing. So I'm like, version maybe several orders of magnitude to what we have now and a few orders of magnitude to what we had a month ago.
Cool. Awesome.
Cool. Thank you.
Great, guys. Great conversation. If you have thoughts or feedback, please send them to me. If you have thoughts on what we should be covering in these conversations, please open a thread or let me know. Yeah, see you next week.
Thanks, guys. Appreciate it.
Thanks.